Hey, guess what? It is fraction action. Yep, time for some fractions coming at you. 5 of them right in front of you. And what do you notice about all these fractions? There's something going on. Like, all these fractions love hanging out with each other. Pause the video, take a moment, stare at them, see if you can notice some things. Okay? It's good for you. All right. Hopefully you pause the video. Because here we go. 4, can you even read them all? Let's start with the first one. This one here. Okay? We're not talking halves here. We're not talking thirds. We're talking eighths in this one. And how many eighths do we got going on? Well, we got 4 of them. We got 4 of them. 4 eighths. So 4 eighths looks over with their glasses, and who do they see? They see this guy here. Who's that? 3 what? 3 sixths. That's a fun one to say. Sixths. It's like a snake. 3 sixths. Okay, well, what's cool about that? Well, 4 eighths is like, whoa. Looking at 3 6, it's like kind of like, whoa, 3 6? We are kind of, what? You just feel like you're my sister or brother. Like, are you? Are you my long lost brother or sister? We seem sort of like we're the same. But yet we have different numbers. What is this? Why do I feel like I'm the same as you? And then 3 6 is like, yeah, I'm feeling the same way, but what's really weird is when I look through my glasses at this guy over here who's standing next to me. Who's this? Well, this isn't 4 eighths, this isn't 3 6, this is 5 tenths. Yeah, and I'm feeling the same way. Like, your numbers are not the same as mine, yet I'm still feeling the same as you. So now, oh my gosh, all of us 3 kind of feel the same, like we're brothers and sisters. And these guys over here are like, yeah, us too. What is this? Did you guys notice this? Did you notice that all these fractions are actually representing the same equivalent amounts? Yeah, what? Okay, look at this. Well, 4 plus 4, if I double 4, it gives me 8. If I double 3, 3 times 2 gives me 6. Does it work again? Double the 5, times it by 2, what do I get? 10. Double the 2, what? I get 4. Double the 6, I get 12. What? All the denominator's bottom number are double the top numerator. Well, let's go the other way. 8, if I go this way, yeah? And I say, all right, what is 4 compared to 8? 4 is half of 8. If I take 8 and I cut it in half, that's the same thing as dividing it by 2. I get 4. 6, cut it in half, divided by 2, I get 3. 10, cut it in half, I get 5. 4, cut it in half, I get 2. 12, cut it in half, I get 6. These actually are all the same family. They didn't know it. But they're all the same equivalent to 1/2. Yeah, that takes some clapping action. Get your hands going. Yeah, just like this. Keep one totally straight. Keep the other one going. Now try the other one. Yeah. Whoa. That's awesome. They're all 1/2. Okay, let's try to make half with different numbers on the bottom denominator. So let's say the denominator is 14 now. What's going to be our top numerator if it's equivalent to 1/2? Well, half of 14, divide that by 2. What times 2 is 14? What number plus itself gives me 14? Well, it's not 1. It's not 2. It's not 3. It's not 4. It's not 5. 6 and 6, that's 12. 7 and 7, that's 14. So there we have it. 7/14 is going to be in the family of the halves. How about 24? Holy moly. If I take 24 and I half that, divide it by 2, what am I going to get? Well, I know 10 and 10, that's 20. 11 and 11, it's 22. 12 and 12, That's where we're at. So this is 12/24. Let's try one more. This one, fabulous right here. 100, half it. Boom. 100 cents. That's what I think in my head was half of 100 cents. 50 cents. That'd be half of $1. So 50 hundredths would be in the family of the halves. Now, why are we doing this? Because when we compare fractions, it's always good to keep half in our head. Because if we can use that to help us compare, man, the problem becomes simple. Okay, let's look at some problems that are more mild and then take on a spicy problem, okay? All right, here we go. This is mild, we're gonna be okay. So with your pencil, you'd write down this fraction here. And how do we read it? Well, we'd say 3, line, no, you're not gonna say line. 3 what? Are we working in halves? No, we're working in eighths, okay? And we're comparing that to what? 4 fourths? No, we're working in sixths. Now, if these were both eighths, that would be super cool. It'd be like super nice, but they're not, they're different. These are eighths and these are sixths. So how can we compare these? Well, first, we could try to use half and say, is one of them more than half and one of them less than half? Because then, boom, I would know the answer of which one's bigger. So let's try that. So I'd say, all right, well, if I'm thinking in eighths, and I draw myself, or you're thinking in your head, you have a number line going on, and you have 0 to 1, and we're working in eighths, so 1 would be the same, equivalent to 8/8. What would half that be? Well, I like 8. Half of 8, that's a nice one to take half of. What number plus itself gives me 8? 4. 4 and 4 give me 8. So 4/8 would be half, but we only have 3/8. So this one is actually less than our half benchmark that we are trying to use. So it exists down here. It's less than the halfway mark, okay? This is our half. That comes from the same family. But over here, we don't have eighths, we have 6. So now, this is all going on in my head. I have a 0 to 1 number line, and I have 6 now. And I'm saying, well, the halfway mark would be how many sixths? Half of 6. What number plus itself gives me 6? What number doubled gives me 6? Well, 1 and 1 is 2. 2 and 2 is 4. And 3 and 3 is 6. So 3/6 would be 1/2. Oh, but we have 4/6. 4/6, you'd be more. You're more than 3/6. You're more than half. So this guy is more than half. So, booyah, I'm able to know whether 3/8 is equal to 4/6, or whether it's bigger, or whether it's less, because I know 3/8 is less than a half, 4/6 is more than a half, so 3/8 has to be less than 4/6, just because of my using half to help me, okay? Now, you might be wondering, well, what does a spicy one look like? Well, let's take a look. Or maybe you weren't wondering, you're like, no, I'm too scared to try a spicy. Well, guess what? It's the only way our brain is gonna grow is to do some tougher problems, all right? And really make our brain go into that mode for just a little bit of time, okay? And I'm here with you, so let's check it out. Deep breath through the nose, out through the mouth. If you didn't do that, do it. It's good for you. It's good for your brain. All right, here we go. Let's check out how spicy. Boom! Oh my gosh! Okay, you might be like, that's not so bad. Okay, well, let me show you like maybe why this one would be spicier than the other one. So here we got 3 what? We're working not in eighths, not in sixths, we're working in fourths. So I'm saying, can I use my half to help me figure out the comparison here? Well, if I'm working in fourths, I know 4/4 would be 1 whole amount. If I go my halfway mark, here's my half, how many fourths are the same as half? Well, half of 4 would be 2, because 2 and 2 is 4. So 3/4 is not equal to a half. It's actually what? It's actually more. It exists over here. It is more than a half, all right? Whereas this guy, we're working with what? Not eighths, not sixths, not fourths. We're working with thirds. Okay, so I go to one whole and I go, okay, one whole is 3/3. Okay, now I need to go half, the halfway mark. Well, half of 3, okay, 1 and 1 gives me 2. 2 and 2 gives me 4. Uh-oh. 3 and 3 gives me 6. Uh-oh, I'm trying to get 3, guys, right here, and it's not there. It's not there. So is it not possible to get 3? Well, it is. It's just the number would end up being 1.5. 1.5 plus 1.5, well, that actually does give you 3. So half of 3 is not a whole number. It's a mixed number, which makes it spicy. And typically, you know, when we draw out and we were to take a rectangle that's the same length from 0 to 1 and cut it up into 3 parts, do you notice our thirds do not hit that half line, right? It's not exact. So 1/3 is gonna be, look at it, less. It's underneath the halfway mark. It's not up to half. Plus 1 is less than our 1.5. So 1/3 was less than a half, 3/4 was greater. So I can say 3/4 is greater than 1/3. You did it! You made it through a spicy, okay? Just keep practicing and using those halves.